This video is going to walk you through the special right triangles discovery. So this is an activity that we would have done in class. So this is just going to work through it with me instead of in small groups. Okay, so first up, use Pythagorean theorem to find the missing side of the right triangles and then simplify square roots. So we don't want decimal answers, we want square root answers. Okay, so thinking about Pythagorean theorem, so that would mean 3 squared, which is 9, plus 3 squared, which is 9, equals c squared, because we know a and b. We're trying to figure out c. So 18 would be c squared, which means c is the square root of 18, which we could simplify that to be 9 times 2, so 3 square root of 2. So this side right here would be 3 root 2. All right, next one. So legs are 7. So a squared plus b squared equals c squared. So we add those together, we get 98. So c is going to be the square root of 98. And we can simplify that to be 49 and 2, so 7 root 2. So this side is 7 square root of 2. All right, number 3. So a squared plus b squared equals c squared. So c squared is 200, which means that c is the square root of 200, which would be 100 times 2, so 10 root 2. So 10 square root of 2. All right, so looking at each triangle, what do you notice about the hypotenuse compared to the legs? Well, in every single question, the hypotenuse was just the leg measurement multiplied by the square root of 2. So each hypotenuse, is the leg multiplied by square root of 2. All right, so now come up with a general pattern for a right triangle with 45-degree angle and legs that measure x. Well, if I look up here, instead of having a number, I have an x. So if this leg is x and this leg is x, then I know the hypotenuse is going to be x times the square root of 2. So the legs are x, and then the hypotenuse is going to be that measurement multiplied by the square root of 2. And then I also want to point out that the legs are the same because those angles are the same right here. So what happens is this one comes out of a square. So if we could think of it as this right triangle is actually half of a square. So we just figured out the diagonal of the square. All right, next up. So this time we're going to use Pythagorean theorem to find the missing side of the right triangle. Change colors because these are different triangles here. So on this one, this is a 30-degree angle, which means this one is going to be a 60-degree angle. And then also for this one, I know the hypotenuse and one leg. So what I'm missing is the second leg. So I'm going to say that a squared plus b squared equals c squared. So I need to subtract 36 from both sides. So then that tells me that a is going to be the square root of 108. And let's see, we can simplify that to be 3 times 36. So that would be 6 root 3. So this side over here is 6 square root 3. All right, next one. So same idea here. So I know one leg and the hypotenuse. So a squared plus b squared equals c squared. So we subtract 9 from both sides. So a squared is 27, which means that a is the square root of 27. And we can simplify that to be 9 and 3, so 3 root 3. So 3 square root of 3. All right, number 6, same thing. So a squared plus b squared equals c squared. So we need to subtract 25 from both sides, which means that a is going to be the square root of 75, and we can simplify that to be 25 and 3, so 5 root 3. So this side is 5 square root 3. All right, so looking at the triangles, how are the 3 sides of the triangle related? Okay, so here's the deal. The short leg is half of the hypotenuse, if you notice that. The short leg is half of the hypotenuse. So the short leg is half of the hypotenuse, which we could also say going in the other direction that the hypotenuse is twice the length of the short leg. And then the long leg is the short leg times the square root of 3. So the long leg is square root of 3 times the short leg. All right, so now come up with a general pattern for a right triangle with a 30-degree angle if the short leg is x. Okay, so if this is 30 degrees, I know this one is 60 degrees. So I'm just going to mention that right there. All right, so let's see. If this side is x, we said that the short leg is half of the hypotenuse, or that the hypotenuse is twice the short leg. So if this one is x, then this side must be 2x, and we can see that the hypotenuse is twice the short leg on each of those. And then this side is going to be the short leg times the square root of 3. So this side would be x square root 3. All right, now this one actually comes out of an equilateral triangle. So I'm going to kind of just draw this out here. That this one is half of an equilateral triangle, which is why the short leg is half of the hypotenuse. And it's also why it's a 30, 60, 90 triangle right there. All right, so now I want to do some examples of problems that you would have in this section. So I am going to move to notebook paper. So these are special right triangles. So let's start with, so there's, just to back up again, there's 2 types of special right triangles. So we just went over those 2, so you might want to keep that sheet handy. So now we're going to do some examples of these. So let's say, starting off with this one. So all of these are right triangles. Let's say I told you that, and I told you that, and then we'll call this side x and this side y. All right, so using what we know, this one is a 30, 60, 90 right triangle. So it's going to follow this pattern down here. So since I know the hypotenuse is 30, I know that the short leg is half of the hypotenuse. So that tells me that this side down here is going to be 15. And then, since the long leg is the short leg times the square root of 3, then I know that this side over here is going to be 15 square root 3. So what happens is, if it's a special right triangle, normally in order to use Pythagorean theorem, you need to know two sides. This lets us take care of this triangle knowing one side. All right, so let's try another one. So let's say for this example, I'm going to tell you that one is 60 degrees and this one right here is 7. So we'll call this X and this Y. All right, so since this is 60-degree angle, I know this side is bigger, and since this is the 30-degree angle, I know that this is the short leg. So if the short leg is 7, I know that the long leg is going to be the short leg multiplied by square root of 3. And then I know that the hypotenuse is going to be twice the size of the short leg, so this side would be 14. All right, next up, let's say, for example 3, how about we have this, and I'm going to tell you that this is 9. All right, so first of all, I know that this one is a 45, 45, 90 triangle because these two sides are the same. So if those two sides are the same, those two angles are both 45 degrees. So if I label this as X and this as Y, all right, I know that those two are the same. So X is 9. And then I know, if you want to look back at what we just did, that if the legs are X, then the hypotenuse is X squared root of 2. So if the legs are 9, the hypotenuse is going to be 9 square root of 2. All right. Now, there's one last type of problem, and we're going to do one for each of these. So, for example 4, move this out of the way. All right, let's see. So, example 4. All right, I'm going to tell you that this is 45 degrees right here, and I'm going to say that this side is 12, and then we'll call this X and Y. All right, so here's the deal. So on this one, this time we know that the X square root of 2 side is 12, and we are trying to go backwards. So basically what we want to figure out is what the X is. So there's different ways you can do this, and I'm going to show you two different ways. I'm going to show you one is like, you know, the real algebra way, and then the other I'll tell you the shortcut. All right, so what I know about this triangle is that this side right here is the side that is X root 2. So if I think about this as an equation, the side that is X root 2 is equal to 12, which means to figure out what X is, I just need to divide both sides by square root of 2. So that will leave me with X is 12 over square root of 2. The problem is that we can't actually get that into a numerical value because we can't divide by something that doesn't end. So this is called rationalizing the denominator. So we need to get rid of the square root that's in the denominator. And the way to get rid of a square root is to multiply it by itself. So if I multiply the square root of 2 times the square root of 2, that will equal the square root of 4, which will equal 2. Oops, I'm off the camera. Hold on. All right. So, you know the rule is whatever you do to one, you have to do the other. So if you think about it, if I multiply this fraction by the square root of 2 over the square root of 2, I'm really just multiplying this fraction by 1. So on the top, I'm going to get 12 root 2, which isn't going to change. But then I can simplify right here and then end up with that side x is going to be 6 root 2. All right, now, since both sides are the same, I know that they are both the same. All right, so here's the deal, is if you look at what I basically did, is I had to, since I was going backwards, I had to divide both sides by square root of 2. So in order to divide 12 by the square root of 2, what I actually did, if you look at this right here, is I took 12, I multiplied it by the square root of 2, and then divided it by 2. So that is a shortcut that you can do. So if you know this side right here, so let's just pretend as another example. Let me find a different color here. All right, we'll do dark purple here. All right, let's say this side is 20. If I know that the hypotenuse is 20, to go to the legs, I need to take this, divide it by 2, which would give me 10, and then multiply it by square root of 2, and that will give me the legs if I know the hypotenuse. All right, now, similar thing could happen with the 30, 60, 90 triangle. So let me show you that one. On a 30, 60, 90 triangle, it's different because the pattern is different. So keep that in mind. So let's say that we have this right triangle, and I'm going to tell you this is 60 degrees, and I'm going to say that this side over here is 21. Okay, so what's going to happen on this one is this is 60 degrees, so this makes this the long leg. And since this is the 30-degree angle, this is the short leg. So remember that the long leg is x squared root of 3. So this right here is x square root 3. So if I bring this to the side and solve it like an equation, if this is x squared root of 3 equals 21, I need to divide both sides by square root of 3, so that cancels, and I get that x is 21 divided by square root of 3. However, we can't leave square root of 3 in the denominator, so what I need to do is multiply this fraction by the square root of 3 on top and bottom. So the denominator becomes the square root of 9, which is 3. And then the numerator is 21 root 3. And that doesn't change. But then I get to this step and I can reduce. So again, just like with the one up here, if I know the side that has or is supposed to have the square root, then you divide by 3 and then multiply by square root of 3. So in the end, my short leg is going to be 7 root 3. So this one right over here. So this side will be 7 root 3. Now the hypotenuse, once I know what the short leg is, the hypotenuse is just that times 2. So if this side is 7 root 3, this side would be 14 root 3. Okay, so what I did is I took this, divided by 3, got 7, and then plopped the square root of 3 on it. So if we do another one, we could do let's say this side is 30. If this side is 30, then I need to go backwards. So divide by 3 and then plop square root of 3. And then to get from the short leg to the hypotenuse, I need to just double this. So 10 square root of 3 would be 20 square root of 3. All right, now you might be thinking, what happens if you have something that can't be divided by 3 or can't be divided by 2? So let me show you one of those. Let's say we had this side, which would be 14. All right, so if this side is 14, we need to go backwards. So if this is 14, this side would be 14 root 3 over 3, because 14 over 3 can't be divided evenly, so we can just leave it like that. And then to get to the hypotenuse, this doubled would be 28 root 3 over 3, because this times 2 is going to be 28. All right, so I would definitely keep this handy. We have this written out. The legs are x, the hypotenuse is x squared root of 2. I didn't write out this one, so if we put this on here, if we think of it this way, is that the short leg is x, the long leg is x squared root of 3, and then the hypotenuse is going to be 2x. So this is the pattern when you have the 30, 60, 90 triangle. So here's your pattern for 30, 60, 90 triangles. And then here is your pattern for the 45, 45, 90 triangles. And then again, just remember that if it's a side where you have to go backwards, then divide by the number in the square root, and then you have to include the square root. All right, good luck.